Hello, my class 10 students. Here I have the first sample paper for chemistry for ICSE board examination. That is the science paper 2, that is of 80 marks. I am going to solve this paper to show you what it takes to get full marks in chemistry in ICSE board examinations. The paper consists of 80 marks, which will be combined with your project marks out of 20, which your school provides, to give you marks on 100 in your ICSE board mark sheet. It consists of two sections, section 1, which is of 40 marks, and section 2, which is also of 40 marks. But section 1 is compulsory. You will have something like MCQs over here, and in your section 2 you will have 6 questions. Each one will be 10 marks, and you will have to solve any 4 questions out of this. Now, since our question 1 is compulsory, let us see how we proceed for solving question 1. Choose the answers given from the option given below. So we have the first part of A. An element with atomic number 19 will most likely combine chemically with the element whose atomic number is, and we have the choices. To begin with, you have to get the electronic configuration. This will be 2, 8, that is 10, and 9 remain. So we'll have 8, and then 1 will be thrown in the next shell. So we have 1 valence electron, okay? And out of this, we have 17, which gives electronic configuration 287. So this will be 1 minus, this will be 1 plus. So most likely it will be combining with A. Now let us look at the other choices. 11, what is it? It is 281, which is a metal. 13, what is it? 283, again a metal. 20, that is 2882, again a metal. Now can a metal combine chemically with another metal? Not possible, so our answer is this. Let's come to the second one. Color of precipitate formed by adding NH4OH solution to iron 3 sulfate. Now the cation is iron 3 sulfate. Remember, NH4OH solution, it detects the cations. Now you can watch my video on analytical chemistry to know the colors of different cations, but here iron 3 will give us reddish brown, so our choice answer is C. Let us come to the third one. Which of the following properties do not match with the elements of halogen family? Now what is a halogen? Halogen is with group 7A or group 17, it will have 7 electrons in the valence shell. So A is 7 electrons in the valence shell, is pertaining to halogen family, so we can't take this because we have to find which does not match. Now, is a halogen diatomic? Yes, because it is 7, so it will share 1 electron with another. So this is also true for halogen, so we can't take this. Highly reactive? Yes, because 7 electrons easily will gain 1 electron, so no. It is metallic. Now, halogen is group 7A, which is a non-metal, so metallic does not match, so that is our answer. We come to fourth subpart. Which of the following pair of metals are extracted only by electrolysis? Now, only by electrolysis, that means they must be higher in the EC series. So, which are the higher in the EC series? Na and Pb? Na, yes, sodium is on top of the EC series, but Pb is not. Ca and Cu? Ca is kind of higher in the EC series, but not copper. Na and Ca both are higher in the EC series. So this will be the prompt answer. Reason? Because they can be extracted only by electrolysis, because you cannot reduce them with normal reducing agent. Now, Ag and Cu, both of them are way below in the EC series, so we cannot take this. So the correct answer is C. Fourth one. Relative molecular mass of MgNO3 twice 6H2O is 256. The percentage of magnesium in MgNO3 twice dot 6H2O is, and they have given us these choices. Now, how much of magnesium is present in this one molecule? The total RMM, relative molecular mass, is RMM. So I will write RMM is equal to 256. But the percentage of magnesium they are asking, so your Mg, the mass of Mg is going to be 24. Now this will have to show the working for, so let us see how we proceed for that. So I have written the answers for question 1A, first part, second part, third part, fourth part, and the fifth part is where we have to calculate. So our calculations, as I told you, percentage of Mg will be mass of Mg upon the mass of whole compound multiplied by 100%. And so after calculations, we get 75 upon 8, and that will be equal to 8 9s 72, remain 3. 3 upon 8 will be 9.8 3s 24, remain 6, 8 7s 56, and 8 5s. Now let's look at our choices. So you will see our choices are these, out of which this will be the correct option. Which of the following is an alkyne? Now alkyne means a triple bond, and we will have the formula CnH2n minus 2. So if it is C5, you will have 5 to 10 minus 2 means 8. This is the correct option. None of these. This will be Cn and this will be 2n plus 2 because this is 8. 3 to 6 and 2, 8. This will be 3 times. So this is also no. This also no. So the correct option is A. We come to the seventh one. The metal oxide which can react with acid as well as alkali is, now remember this means it is amphoteric. And amphoteric means it will be Zn, Al or Pb. Which one of them belong to that? Obviously, it will be aluminium oxide. So the option is C. Number 8. Carbon dioxide and sulfur dioxide can be distinguished by using, can we take moist blue litmus paper? No, because both of them are acidic. So we can't take this. Lime water, both make lime water turn milky. So I can't. Can I take acidified potassium dichromate paper? Yes, because carbon dioxide will have no effect on it, but sulfur dioxide is going to turn this from orange to clear green. Potassium iodide paper is not the test for either of these. Now we come to the ninth one. Sulfur atom gains 2 electrons in its valence shell to acquire a stable electronic configuration of the nearest noble gas. Now sulfur is going to gain 2 electrons, so it is will become. Now which one is this noble gas? It is 3 shell, so it is period 3. So period 3 group 18 is going to be 282 argon. Neon is 2,8. Helium is 2, argon is 282. Let us look at 10. The aim of the fountain experiment is to prove HCl is lighter than air? No. Denser than air? No. It is highly soluble in water? Yes. And then HCl fumes in moist air. This again it doesn't prove because this is not the direct consequence of this. HCl fumes in moist air because it is highly soluble in water. So fountain experiment does not prove this. It proves C. So our question 1A looks like this. This is of 10 marks. Let us come to part B. Question 1B is name the following. Number 1, a salt formed by incomplete neutralization of the acid, which means the acid must be having more than 1 hydrogen ion per molecule of it in aqueous solution, which means you are going to have some salt which will have H also in that. That will give us the acid salt. The metal present in cryolite other than sodium, cryolite is the ore of aluminium. So apart from sodium, it will be aluminium. Catalyst used in the manufacture of nitric acid by Oswald's process. Oswald's process, remember, it starts with catalytic oxidation of ammonia, and you must know the catalyst because conditions are very important. So it is going to be platinum. Fourth one, the first homologue whose general formula is CnH2n, which means that this is alkene with double bond. So the first one will be with 2 carbons, so that they will be a double bond. So our name of the first homologue will be ethene, so we will write ethene. Metal present in period 3 and group 1 of the periodic table. Period 3 group 1 is sodium. You have to know the order by heart. Let us see how we write the answers. You see the way it has to be written. Let's move on to part C. Part C asks us to write one observation. Number 1. Ammonium hydroxide is first added in small quantity and then in excess to the solution of copper sulfate. Now here our keyword is copper. Copper is with ammonium hydroxide. It is going to give us copper hydroxide. So copper sulfate with ammonium hydroxide will give us copper hydroxide. And copper hydroxide is blue precipitate. It is insoluble. But if we allow excess of ammonium hydroxide to be added to that, this copper hydroxide dissolves, forming tetraamine copper 2 sulfate, and that is inky blue in color. That is inky blue solution. So we will write just that. See how we write the answer? We have to underline the keywords. So put this video on pause and write it down, underline the keywords. This is the way we have to present it. Second one, sugar crystals are added to a hard glass test tube containing concentrated sulfuric acid. Now sulfuric acid concentrated is a dehydrating agent. Sugar crystals will get dehydrated and black spongy mass will be remaining. Now when we write the observation, don't write the reason, just the observation, like so. Black spongy mass of carbon, can you see the keywords are underlined? And colorless vapors of steam are evolved. Even if you don't write this, this is fine, but this is the main observation. Let's move on to the third one. Third one, copper is added to concanitric acid. Now concanitric acid, when it reacts with metal, it will liberate NO2 as the gas. And do you know the color of NO2? Yes, reddish brown vapors. And copper is pinkish metal. It is going to make it copper nitrate, which will be blue solution. Alright, so let us write just that. Reddish brown vapors of nitrogen dioxide are evolved and the solution becomes blue in color. You can put this on pause and write it down fast. Okay. When ammonia is passed through Nessler's reagent. Now ammonia with Nessler's reagent gives brown colored precipitate, correct? So the solution turns brown. So you are going to write just that. This is a test for ammonia, right? Nessler's reagent turns brown. The way we have written, underline this brown so that the examiner knows exactly the keywords and can easily give you marks. The fifth one and the last one of part C, when lead nitrate is treated with dilute HCl. So lead will combine with this Cl, double decomposition reaction takes place and we will get lead chloride, which is chalky white precipitate. Now the entire description of lead chloride you should be able to write. Now with this we have finished 10 and this 5 and 5, 20 marks. Yeah, so let us see how we write this, and that completes 20 marks. Let us write our observation. So a chalky white precipitate of lead chloride is formed, which is insoluble in dilute HNO3 but soluble in hot water. Now this is what you have to know by heart. This is the entire description of PbCl2. So with this we finished 20 marks of section 1. So that is halfway through. This should take you approximately 20 minutes. Okay. Question 1D asks us to write the balanced equations for the following reactions when methane undergoes complete combustion. So let us see how we write it. Our methane is CH4 and plus O2. On heating, C becomes CO2 plus H becomes H2O. CO2 is a gas and this also will be steam. Now here you will see oxygen is even number, so I'll make this even. Oxygen here, so our hydrogen is balanced here, carbon is balanced here, and oxygen is 2 plus 2, that is 4, so that is a balanced reaction. the second one, when excess of ammonia reacts with chlorine. Now, excess of ammonia reacting with chlorine, you need to know this reaction by heart. So we will have ammonia and plus chlorine. Excess of ammonia uses 8 molecules of ammonia with 3 chlorine molecules, and that will give us 6 NH4Cl plus N2 up arrow. These are some of the reactions which you have to know by heart. So this is how the whole reaction looks like. We have to know this reaction by heart. Third one, catalytic oxidation of ammonia to nitric oxide. So we have NH3 plus O2. Catalytic oxidation will give us NO plus H2O plus heat. Okay, and our reaction is 4NH3 plus 5O2 with platinum with 700 degrees C to 800 degrees C. That's the temperature. It will give us 4NO plus 6H2O. This is a gas, and this is again gas. It will be plus, it will be 21.5 kilocalorie heat. We come to the fourth one, action of dilute hydrochloric acid on sodium sulfide. Now sodium sulfide with sodium Na and S, it will be Na2S, and dilute hydrochloric acid. We will write the reaction. Na2S plus HCl dilute. Now if you are confused about this, you can make this double decomposition like so, and we will have 2 Na will take 2 Cl because it will become NaCl, and 2 Na with 2 Cl, so I'll have to write 2 here. That will give me 2 NaCl, right? And plus it will give me H2 with S. It is going to give me H2S, and H2S is a gas, so we will show it like so. The last reaction, when copper nitrate undergoes decomposition. Now all the nitrates are important. You must know all the decomposition reactions of these nitrates by heart. Okay, so let us see how we write it. The fifth one, copper nitrate. All nitrates are going to be 2 molecules on decomposition is going to give us 2 CuO plus 4 NO2, which is a gas, and plus O2, which again is a gas. You have to know these by heart, and also the observations, extremely important. Okay, now we have question 1E. Identify the gas evolved. Dilute hydrochloric acid reacts with sodium sulfite. Now this is sulfite, which means it is H2SO3 it will form. With hydrochloric acid it will form H2SO3, and so the gas evolved is going to be sulfur dioxide. When calcium hydroxide and ammonium sulfate mixture are heated together, that's the second one, we will have double decomposition like this happening. Can you see this? NH4OH. NH4OH is unstable, and so it will liberate ammonia gas. Now ethyne undergoes hydrogenation reaction. We will have C triple bond C will become C double bond C will become C single bond C. So which is the gas? Ultimately, in the last step, we will have ethane gas here. So we have the answer to this one is ethane. Okay, then sulfur is treated with nitric acid. Concentrated nitric acid will give us the product as nitrogen dioxide gas. Remember, concentrated nitric acid gives you NO2 gas, that is nitrogen dioxide. Sulfur becomes sulfuric acid. It will not become SO2. The gas used as a reducing agent for reducing copper oxide to copper. Now copper oxide will have this oxygen removed. So the gas that is used as reducing agent, the reducing agents are C, CO and H2. Okay, so you can have hydrogen as the gas. Now see what I have discussed. I have written this down as my answers, and remember I'm not writing the formula. If I write the formula, how much I'll get? 0. So you have to spell it out. Okay, put it on pause so that you can write this down neatly, and you saw the thinking that went in getting these answers. All right, with the questions up to E, we have finished 30 marks. It should take you 30 minutes. Now we come to F and G. These two should take you 10 minutes. Now you will see that F is match the following. So it should take you very less time. Okay, give reasons is going to take a long time to write because you have to write the entire reasoning. So be quick when you have objective questions like that so that the entire section 1 finishes in 40 minutes. All right. So question 1F is match the column A with column B. Now sodium chloride is an ionic bond. It is not going to be polar covalent bond. So first one is D. We have electronegativity across the period. Now across the period, remember atomic size and metallic character decreases and down the group it increases. Now remember, electronegativity is not ATM. So every other property, which is your IP, EA, EN, and non-metallic character, these ones are going to increase across because ATM is decreasing, and down the group ATM increases. So all these are going to decrease down the group. So electronegativity across the period electronegativity will increase. So where is increases? Here. Got that? Non-metallic character down the group. Now down the group metallic character increases, so non-metallic is going to decrease. So we have decreases, that is E. So this is going to be E. Hydrogen chloride gas is going to be hydrogen and chlorine. They are going to have the electron pair unequally distributed, so polarity will be exposed, and so you will have C. It will be a polar covalent bond, and carbon tetrachloride is going to be where the electron pairs will be distributed equally, so non-polar covalent bond will be there, so this will be B. So let us see how we write it down. Here we are. We write it like so. Okay, let's move on to G. Give reason for the following. Hydrogen chloride gas cannot be dried over quicklime. Now what could be the reason? Because quicklime is a hygroscopic substance, but it is going to react with HCl, correct? And so we cannot dry it over it because chemically it is combining, right? So we write hydrogen chloride chemically combines with quicklime. It forms calcium chloride. Hence, although quicklime is hygroscopic in nature, what does hygroscopic mean? It absorbs moisture. It cannot be used to dry hydrogen chloride. So it's better to use the chemical term here in order to get our 1 mark full. G second part. Electrolysis of acidulated water is considered to be an example of catalysis. Now catalysis is where we have catalyst as the acidulated water means dilute H2SO4 added to it. That becomes the catalyst for electrolysis to happen. Okay, that's how it becomes catalysis. So we'll write just that. I have written pure water is a non-electrolyte, and addition of dilute sulfuric acid helps in dissociation of water. Remember, it's the dissociation of water that is going to cause the electrolysis. So unless and until dissociation of water takes place, we cannot have electrolysis taking place. Thus, sulfuric acid acts as a catalyst in electrolysis of water. Hence, electrolysis of acidulated water is an example of catalysis. Let's look at the fourth subpart. The oxidizing power of elements increases on moving from left to right along the period in the periodic table. Now, oxidizing power of elements. What does oxidizing power of element mean? Oxidizing power on the right hand side, from left to right. On the right, there will be non-metals, and non-metals, they gain electrons. Now, when they gain electrons, they make the metals which are on the left hand side lose electrons. So, when oxidation of the metals takes place by metals losing the electrons, that is gained by the non-metal which is on the right hand side of the periodic table. Got that? So that is why the oxidizing power increases from left to right. Let's see how we write it. Sorry, the earlier one was second one and this was the third one. I made a mistake. I said this was the fourth one. So the periodic table has non-metals on its right. So on the right, what do we have? We have the non-metals. And non-metals, they gain electrons in order to acquire stable electronic configuration. So, gaining electrons reduces them. These electrons are lost by the metal atoms which are on the left. So, when they lose these electrons, it oxidizes them. And hence, from moving from right to left, the oxidizing power increases. Number 4. Electrolytic reduction of alumina is a continuous process. Now for electrolytic reduction, remember alumina dissociates as 2Al2O3 dissociates into 2Al3 plus 3O2 minus, correct? Now this aluminium is going to accept electrons and it is going to get deposited. And so the amount of alumina in the electrolytic bath reduces. As a result, the resistance of the electrolyte increases and the charge lamp glows. The moment charge lamp glows, we add more alumina and that alumina again gets dissociated and it deposits aluminium at the cathode. So it's a continuous process. Why? Because of the charge lamp. So we will write just that. During electrolytic reduction of alumina, as it dissociates into Al3 plus and O2 minus ions and aluminium gets deposited as a metal at the cathode, the amount of alumina in the electrolyte decreases. Obviously, alumina has dissociated, so the amount of alumina in the electrolyte has become less. This increases the resistance of the electrolyte and the charge lamp glows as an indication to add more alumina. So as we add more alumina, again the same process repeats and again the charge lamp glows. So you saw the keywords that I've underlined. Thus it is a continuous process. Now put this video on pause, write it down, underline the keywords and learn what are the keywords. Okay. The fifth one, covalent compounds have low boiling point. Now covalent compounds have only molecules which are held together by weak van der Waals forces. And so you see that when we apply heat, the particles are going to have the weak van der Waals forces overcome with lesser energy because they are weak bonds. So when you supply less energy, the molecules are going to separate, which means the boiling point is going to be at less energy level, which means lesser temperature. So we will write that in this form. So we have covalent compounds have their molecules held together by weak van der Waals forces. So this is the first keyword, which are overcome by addition of less heat. What is overcome? These weak van der Waals forces are overcome by addition of less heat. Thus, the molecules are separated at a lower temperature and they have low boiling point. Okay, put this video on pause, write it down, underline the keywords. With this, we have finished section 1. Alright, so that is 40 marks complete. Now we'll start with the section 2. As I said, section 2 will have 6 questions and it will be question 2, 3, 4, 5, 6 and 7, out of which we have to solve any 4 questions of 10 marks each. Alright, So let us look at this. Consider the section of periodic table. This is the periodic table given to you. In this table, B does not represent boron, C does not represent carbon. So these are just the letters of alphabet. So we have A, B, T, D, Y, G, J, H, Y, L. These ones are the letters of the alphabet, but lithium is a metal, magnesium is a metal, silicon, this F also is just the letter, it's not fluorine. Fluorine should be somewhere here. Yes, okay, this is, yeah, this oxygen is correct, this neon is correct, yeah. Now what are they saying? Some elements are given in their symbols and positions in the periodic table, while others are shown with a letter with reference to the table. Let us see what they have to say. Which is the most electronegative element? Now, most electronegative element in the periodic table, you must know the full list, which has the maximum atomic size, maximum ionization potential, electron affinity, electronegativity, non-metallic character, metallic character. You should know that list by heart. So, most electronegative is fluorine. Now, where is fluorine? Fluorine is period 2, group 7A. So fluorine, we can't write fluorine, we have to write J. How many valence electrons are present in T? Where is T here? Now T is in group 2A and it is period 4. Period 4 means it is having 4 shells. So it will be 2, 8, 8 and 2. Why 2? Because it is in group 2A. So how many valence electrons are present? 2 electrons. Write the formula between compound formed between B and Y. B is here and Y is here. Now can you see there are 2 Y's over here, but we cannot take this Y because B is a metal and group 3 also has a metal. Now we don't have metal and metal combining together. We have metal will combine with a non-metal only. So there is a mistake in this paper. Alright. Now in case we have a mistake in the paper, we have to use our discretion and use this. Okay. So it will be B with 1 plus because it will lose 1 electron. So I'm writing here B with 1 plus, and this Y is group 17, which means it is 287. So it will have 1 minus as the valency, and so the formula is going to be, when we do crisscross here, it becomes By. That is the formula. Identify the type of bonding present between the compound between the elements A and Y. Now A and Y, it's going to be exactly the same. A is again group 1. So it will be A1 plus valency, and this Y is going to be 1 minus, and here it will be A losing 1 electron and Y gaining that electron. So the type of bonding is going to be ionic or electrovalent. Identify the element of group 2 of periodic table which would have least ionization potential. Ionization energy means least ionization potential. Now group 2 is here. From group 2, which will have least ionization energy, here we have to consider this box that has been given. So it will be T. Why it will be T? Because remember, as I told you, I shall write this side, ATM decreases this way and increases this way. Correct? So atomic size and metallic character down the group increases, but they are asking for ionization potential. So if ATM increases, IP is going to decrease, and so the least ionization potential will be here. IP will be less over here and IP will be more over here, more over here. Okay, understood? Because going down the group, IP, that is ionization potential, decreases. So you will have your answer as T. Now, if you found some of this part confusing, then pause it or go back, rewind, go back a little bit and listen to the explanation once again. All right? So how we write the answers? Do not write the full statement. This much is more than enough. Let's write our paper fast. Question 2b. An organic compound with vapor density 94 contains C 12.67%, H 2.13% and Br 85.11%. Find the molecular formula of the compound. The atomic masses are given. So we have to make the columns for this. Let's do just that. We have made this table. Everyone knows how to make this table. So we write the carbon, hydrogen, bromine and their percentages, their atomic weights and the relative number of atoms. How do you get relative number of atoms? Percentage upon atomic weight. So it becomes 12.67 upon 12. Here it becomes 2.13 upon 1 and 85.11 upon 80. Now here the easiest calculation will be 2.13 divided by 1. Okay. Now for our rough column, it's wiser to have rough column done here itself. You can use either your pen or pencil to do the long division. I'm using pencil here. So 12 will be dividing 12.67. 12 ones 12. And then we take this 6 decimal point and 12 will go here 0 times. Then we'll take this 7. So 12 fives 60. Then again 12 fives 60. Then we will have this one. So 80 divides 85.11. So 80 ones 80 remain 5. Then we take 1 here. 80 is too big for this. So we will write decimal point and 0. And then we will take the next digit down. So it will be 648, right? So 480, correct? And then here it will go 8 fours 32. So 80 fours will be 320. So it will go 3 times, correct? So let us see here. This is 1.055. Now can you see this is 1.06? I am going to round this off to 1.06. Okay, so that it will have the same number as this. Alright, I am not taking the third decimal place. I am going to take till 2 decimal places. Now simple ratio means you are going to divide each one of them with the least number. So 1.06 upon 1.06, that will be 1. 2.13 divided by 1.06, which will be, now can you see 6 2's 12. So 0 6 2 is 0.12. So this is going nearly twice. Yeah. Now this is 1.06 upon 1.06, that will be 1. So you saw carbon is 1 atom, hydrogen is 2 atoms and Br is 1 atom in the empirical formula. So we will write empirical formula and that will be CH2Br. But now we are expected to find its molecular formula, right? So we have to find empirical formula weight will be equal to C means 12 plus H2 means 2 into 1 and Br is 80. 12 plus 2 plus 80. That gives us 94 as the empirical formula weight. Now we need the molecular formula weight, which is also the RMM. It will be 2 into vapor density. We already know this formula. So that will be 2 multiplied by, can you see it is given 94 as the vapor density. So your N is equal to molecular formula weight upon the empirical formula weight, which will be 2 into 94 upon 94, which got cancelled, and then we will have molecular formula is equal to N into empirical formula, which will be N into CH2Br. That will give us 2 into CH2Br, and that gives us C2H4Br2. So this is our answer. They can even ask you write the IUPAC name of this. They can even ask you to draw the structural formula for this. Correct? And also they will say which compound was it when treated with bromine gave us this. So prepare these questions for y'all. Okay? Question 2C. Acids dissolve in water to produce positively charged ion. Draw the electron dot structure for the formation of these ions. These are the hydronium ions, and you should know the diagram for this by heart. Okay? We show water like so, with oxygen with its 1, 2, 3, 4, 5, 6 electrons, which are shown with the small round. And these crosses are the electrons of hydrogen, which are shared with these. So we have oxygen with one shared pair with this hydrogen and one shared pair with this hydrogen, and these two are the lone pair of electrons which are going to be responsible for formation of this hydronium ion. So we have this hydrogen ion coming in, that is hydrogen ion I have written over there. This hydrogen has no electrons, so it needs 2 electrons to complete its duplet. So this electron pair is going to get accepted by this hydrogen, and that is going to form the coordinate covalent bond. See what has happened? This structure of water as it is, and this pair of electrons has been shared with this hydrogen, and the whole structure will have 1 plus charge, showing one lone pair of electrons. And then in the next step we will show this as a single covalent bond, this as a single covalent bond, but this one is the coordinate bond, coordinate covalent bond, and we show this one lone pair, and then that will have the hydronium with 1 positive charge. This becomes H3O 1 plus, which is hydronium ion. You have to know this by heart. Okay, practice this maybe 5 times, 10 times. It should know. Middle of the night, anybody asks you, come on, middle of your sleep, draw this, you should be able to draw. So that well your preparation should be. All right. We are on question 3. A says mention the property of sulfuric acid exhibited in each one of the followings: with NaNO3, with zinc, and with sulfur. Now with NaNO3, when we take sulfuric acid, we use conc sulfuric acid, and NaNO3 plus H2SO4 conc will give us NaHSO4 and HNO3. In this, sulfuric acid is used as a non-volatile acid. It is used as a non-volatile acid. We come to the second part. With zinc. Now zinc and sulfuric acid, Zn plus H2SO4, will have to use dilute H2SO4. That will give us ZnSO4 plus H2. What property of dilute sulfuric acid do you see over there? That is the acidic property. So it is our dilute acid property, or you can even write it acidic nature. With sulfur, sulfuric acid will oxidize sulfur to sulfur dioxide. So the property that we have for sulfur is oxidizing property. Let us look at B. Select the correct atomic numbers 4, 8, 15, 12 with the description given below. A gaseous element with valency 2. Now for that, you will need the electronic configuration of each one of them. Now, if it is 4, it will be 2, 2. If it is 8, it will be 2, 6. If it is 15, it will be 2, 8, that is 10, and 5, 15. And if it is 12, it will be 2, 8, that is 10, and 2. You should be able to write the electronic configuration without hesitation for this. If you are not comfortable with this, practice this. Alright? Now, a gaseous element with valency 2. Now, gaseous element will be a non-metal. And the non-metal with valency 2, which means it is 2 minus, which means it will have 6 valence electron. Correct? So 6 valence electrons, where it is 8. So we have first one 8. And the rare gas, where is the rare gas here? We come to question 3C. Equation for the reaction when compound A is bubbled through bromine dissolved in carbon tetrachloride is as follows. So compound A with bromine is becoming CH2Br, single bond CH2Br. Draw the structure of A. Now, if bromine has got added to this, this is CH2Br and this is CH2Br. So this is the structure of this. Okay, this is this. Now bromine has got added up, which means earlier bromine was not there. So this must have been a double bond. So your A must be C here and C here with a double bond. And it will have H here, H here, H here, H here. And this bromine opened up this valency so that it became from double bond, it became single bond and bromine got attached over here. So draw the structure of A. What is A? A is ethene. So let us see how we write it down. A is ethene. And the structure will be C double bond C with H, 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 H here like so. Then we come to, this was the first part. Second part says, state your observation during this reaction. Now during this reaction, bromine in CCl4 is reddish brown bromine. But when it got added up over here, this bromine reddish color from this inert solvent CCl4 bromine is gone. And so the reddish brown color of bromine is discharged. Okay. Now we come to part D of question 3. The following questions are related to preparation of nitric acid. Number 1. What is the special feature of the apparatus that is used in the laboratory preparation of nitric acid? Special feature is that all apparatus is made of glass. So all glass apparatus is used. Why should the temperature of the reaction mixture of nitric acid not be allowed to rise above 200 degrees C? You know what happens above 200 degrees C? Sulfuric acid that is reacted with our sodium nitrate that forms Na2SO4, which forms hard crust, and also nitric acid will tend to decompose at a higher temperature. So we will write just that. If the reaction temperature rises above 200 degrees C, then sodium sulfate is formed, that is Na2SO4, which is hard crust, difficult to remove, it wastes fuel, and also at higher temperature nitric acid may decompose forming nitrogen dioxide and water. So that is why the temperature is kept less than 200 degrees C. Distinguish between dilute sulfuric acid and dilute hydrochloric acid using barium chloride. Now these questions are very, very important because they use analytical chemistry. You will have to make 3 columns, one for the test, one for dilute sulfuric acid and the other one for dilute hydrochloric acid. If you use barium chloride with sulfuric acid has got SO4 radical, so it will become barium sulfate. And this is hydrochloric acid, so barium chloride will remain barium chloride because here it is having HCl, so the negative radical is Cl, and so there will be no visible change. So let's see how we write it down. So we have made the 3 columns. First one is for the test. We add barium chloride solution to each acid, and then barium will take sulfuric acid ka sulfate and it will become BaSO4, which is a white precipitate insoluble in dilute HCl. If this is so, then SO4 2- is present, and therefore we will say dilute sulfuric acid is present. But barium chloride with hydrochloric acid, with this chlorine and this chlorine, there will be no change, no reaction, and therefore if there is no change, then dilute hydrochloric acid is present. We come to question 4. The following questions are related to the manufacture of ammonia. Name the process. It's Haber's process. You have to know all the processes of all the compounds. Why is a higher ratio of hydrogen taken in this reaction? Now, ammonia is N2 plus H2. Why do we need more H2? Name the catalyst used in the process. Give the balanced chemical equation involved in the process. Name the drying agent used in the laboratory preparation of ammonia gas. So let us write them one by one. Question 4a. Name the process was the first question. So we write Haber's process. Now we come to the second part. Why is a higher ratio of hydrogen taken in the reaction? The reaction for Haber's process is N2 plus 3H2 with reversible reaction gives us 2NH3 plus heat. So one molecule of nitrogen combines with 3 molecules of hydrogen to produce 2 molecules of ammonia. So if we want better yield of ammonia, we will have to take the ratio of N2 and H2 in the ratio 1:3. So we have to take higher ratio of hydrogen because of the reaction. So we'll write the volume and the number of molecules are proportionate. Equal volumes will have equal number of molecules. That is Avogadro's law. The volume and the number of molecules are proportionate, and hence higher ratio of hydrogen is taken in the reaction. Now we come to the third one. Name the catalyst. The catalyst is finely divided iron. Give the balanced chemical equation. I've already written it, but now we will write it with all the conditions, and name the drying agent. So third, fourth, fifth, let us write the answers and let us see how we are going to present our work. So we written the catalyst, finely divided iron, balanced reaction, N2 plus 3H2 with reversible arrow, 2NH3 plus 22,400 calories heat. Conditions for this reaction, catalyst, promoter, temperature, pressure. You have to know all this by heart. And then the fifth one, drying agent. For ammonia, it is calcium oxide. Okay. 4b. Give balanced chemical equations for the following. Aluminium oxide is treated with sodium hydroxide solution. Copper oxide is treated with dilute HCl, and zinc sulfate is treated with ammonium hydroxide. So Al2O3 we will be adding with sodium hydroxide, that is NaOH. Here CuO plus dilute HCl and ZnSO4 with ammonium hydroxide. Let's see how we write it. So our first reaction is Al2O3 and NaOH. Now remember, this is an amphoteric oxide. So with alkali, it will form a complex salt. It will be NaAlO2, and it will form this salt plus water. So now we have Al2, so that will make this be balanced to 2. So we will now balance Na, which is 2, with 2 coming here. So Al2 and Al2 is balanced. 2Na and 2Na is balanced. How many H's do you see? 2. How many H's do you see here? 2. Now how many O's do you see here? There are 3 and 2, 5. Here 2 2's 4 and 1 5. So this reaction is balanced. Now CuO plus HCl. This is a base, this is an acid. So we have neutralization happening like so. So Cu will take Cl, it will become CuCl2. So to balance this Cl2, we will write this, and H2O will be the second product. In the third reaction, ZnSO4 plus NH4OH, you will have this, and Zn will take OH, it will become ZnOH twice. And to balance that OH, we will write 2 here, so 2 OHs will be balanced. Now 2 NH4 and SO4, so it becomes NH4 twice SO4, and this ZnOH twice is a precipitate. Now this is when we have NH4OH little or it is insufficient. Then in the excess we will have ZnOH twice plus NH4 twice SO4 plus NH4OH. That is going to give us a complex salt which is going to form a soluble solution. Okay, but as of now this should be enough for our reaction. Nobody's asked us about excess of NH4OH, so let's move on to the next part. What do you observe when a moist starch iodide paper is shown near a test tube containing chlorine gas? What will happen to starch iodide paper? It will turn blue-black. When iron 2 sulfate is treated with excess of sodium hydroxide solution, iron 2 with sodium hydroxide will form FeOH twice, which is dirty green precipitate, which is insoluble in excess. So you see, we have written just that by underlining the keywords. Can you see that? Yes? Okay. That finishes our question 4. Now we come to question number 5. Remember, from section 2 we have to solve only 4 questions. So now it's time for question 5. Question 5a. When dilute HCl reacts with silver nitrate solution, a white precipitate is observed. Identify this precipitate. Now silver will react with this chlorine and it will combine forming silver chloride. So what is the precipitate? Silver chloride. What do you observe when dilute HCl is treated with methyl orange? Now dilute HCl is acidic in nature and methyl orange is orange in color, and it turns pink in acidic and yellow in alkali. So here the color change will be from orange to pink. Write the balanced chemical equation for the laboratory preparation of hydrogen chloride gas. Now if I have hydrogen chloride gas, I will take something that will give me H and something that will give me chloride. Okay, so for hydrogen I have to take H2SO4 concentrated sulfuric acid, and for chloride I should take either sodium or potassium chloride. Now remember, sodium and potassium chloride are plentiful, so we have to start with NaCl and H2SO4 and we will react them. I will show you how to write the reaction just in a bit. And what is the method of collection of this gas? Collection of this gas is going to be heavier than air. So you will have the gas going down and air coming up. So it will be collected by upward displacement of air, And then the last one, write a precaution which is needed in the laboratory preparation of HCl, which we will write just now. To answer those questions, it's better to write the reaction because it's a simple double decomposition reaction and the precipitate that you get is silver chloride. So I've written just that. Then second one was methyl orange when it is added to dilute HCl. Remember, it is orange to pink. In acidic, in alkali, it will be orange to yellow. We have to remember these colors. Then we have the laboratory preparation, NaCl plus H2SO4. We just make a box like this for partial double decomposition. So Na will have HSO4 giving us NaHSO4 as one of the products, and one H will take that Cl, it will become HCl. The fourth subpart says collection of HCl. How will you collect it? Because HCl is heavier, it will push the air up. So we'll say upward displacement of air. And the fifth part asked us what is the precaution. So the precaution in this laboratory preparation is that temperature must not be more than 200 degrees C. And the other one is that the end of the thistle funnel should be right inside the acid. Okay, otherwise the gas will escape from the thistle funnel. All right, so if they ask you two precautions, you can write the second precaution as that one. They asked you what is the precaution, this should be more than enough. Let's look at 5b. Identify the following substances which are underlined. A metal cation which imparts lilac color to the flame, and that will be potassium. A catalyst used in the catalytic hydrogenation of ethene. Catalytic hydrogenation is going to be with nickel and 300 degrees C. An acid which is tribasic in nature. Tribasic in nature will have 3 hydrogens. So you can write H3PO4 or H3PO3. An electrolyte used in electroplating of silver is sodium argentocyanide, a weak alkali that undergoes partial dissociation to liberate hydroxyl ions in water is going to be NH4OH. Okay, so let us see how we write these answers. So this is how we write. We don't write KNiH3PO4. We have to write the names like this. Okay, that finishes our question 5. Let us now come to question number 6. A. The following questions are related to extraction of aluminium. Name the process by which the impure ore of aluminium gets purified by using a conch solution of an alkali. This is Bayer's process. Number 2, write the temperature required for the electrolytic reduction of alumina. Now, alumina is Al2O3. Okay, now the temperature at which it is reduced. So the temperature for electrolytic reduction of alumina is 950 degrees C, and the earlier answer was Bayer's process. The next question, name the gas evolved when alumina undergoes electrolytic reduction. Now alumina is Al2O3, which dissociates into 2Al3 plus 3O2 minus. So the gas evolved will be because 3O2 minus migrates to the anode and it will give out those electrons and it will become oxygen gas. So number 3 is oxygen. Fourth subpart, write the balanced chemical equation for the following. The formation of aluminium at cathode during the electrolysis of alumina. Now, aluminium at the cathode will be because the aluminium cation will migrate to cathode, it will gain electrons and it will become aluminium, correct? And the B part is action of heat on aluminium hydroxide. So let's write the answers. A part was Al3 plus, but alumina gives out 2 ions of aluminium and they will gain 6 electrons and they will become 2 atoms of Al. So this is the reaction for formation of aluminium. And B reaction is action of heat on aluminium hydroxide. So we have AlOH thrice, which will be at 1100 degrees C. It forms Al2O3 plus H2O. Remember, a hydroxide on heating gives oxide and water. There is Al2, so we will write 2 here to balance that Al. Now you will see how many H's are there. There are 6, so you will have 3 H2O to balance 6 H. And how many oxygens are there? 6 here, 3 and 3, 6, and the reaction is balanced. Let us come to the fifth subpart. A layer of powdered coke is sprinkled over the electrolytic mixture during the electrolytic reduction of alumina. Give reason. Now this powdered coke is going to prevent the oxygen from oxidizing the graphite anodes. The carbon in the graphite anodes is going to get consumed because of that oxygen which is liberated. So it's going to prevent that, and also it is going to prevent the heat from escaping the electrolytic bath. So we have to write just that. So I have written that the layer of powdered coke prevents the anodes from being oxidized and getting consumed. So carbon anode gets oxidized to CO and CO2 and it gets consumed, it gets wasted. Also, it prevents the heat loss by radiation. Now, why this is so? Because oxygen, which is formed at the anode, oxidizes carbon electrodes where it emerges from the bath. So this finishes our 6A. Now we come to 6B. Let's read it. Question 6B is match the following. So we have column A to be matched with column B. Metal with large atomic radius. Which one will be large atomic radius? The one which will be at the left of the periodic table. So it has to be a metal. So it will be C. The metal that does not react with the dilute H2SO4 is going to be copper. Non-metal which conducts electricity is graphite, and a solid non-metal which belongs to period 3 will be phosphorus. So here we have, this is C, this is copper, this one is D, and this one is B. CADB. So we'll write just that. C A B D. And that finishes our question number 6. Now we come to the last question. Now remember, I'm solving all the questions. I am solving all the questions, but you don't have to solve all the questions. You have to solve only 4 from section 2. So let us look at our last question, and the last question is question number 7. Questions below are related to the electrolysis of fused lead bromide. Number 1. Solid lead bromide is not used as an electrolyte. Explain. Now here the key word is solid. Why it should not be solid? Because lead bromide, what kind of compound it is? It's an electrovalent compound. It's an ionic compound. And so it is going to have rigid solid structure, and the ions are not going to be free because they are held together by strong electrostatic force of attraction. So if the ions are not free in solid state, it cannot conduct electricity, so it will not be an electrolyte. See the way we write the answer? Lead bromide is, first of all, we write that it's an electrovalent compound. And so it will have the ions held together by strong electrostatic force of attraction. And so main important keywords, ions are not free to conduct electricity in solid state. And so it cannot conduct electricity, is a non-electrolyte. So can we use it as an electrolyte? No. So you cannot use it as an electrolyte. Hence, okay, let us come to the next subpart. Write the cathode reaction involved in the above process. So we are going to have Pb2 plus and Br1 minus ions. At cathode, the cations will migrate. And so it will be Pb2 plus 2 electrons gives Pb. This is an ion and it becomes atom here. Third, state the observation at the anode. Now at the anode, we are going to have bromine vapors. So what is the observation? Anode has anode has reddish brown vapors of bromine. So that will be our observation. Fourth subpart. Name the electrode chosen for this electrolysis. Which electrode is chosen for this electrolysis? Will it be iron or will it be graphite? Because your bromine vapors, they are highly corrosive, they are highly reactive, so iron will get affected. So we are going to use graphite. So we write just that. Actually, the examiner should have asked you which electrode is used as an anode. Okay, because anode is more important. We come to the next one. Select the preferable ion which gets discharged most easily in an aqueous medium from this bracket. Now the one which gets easily discharged has to be lower in the EC series. So out of these, which one is the lowest? Silver. Okay, so we are going to write. That finishes our A part. 7b. The following questions are related to organic chemistry. Write the structural formula for two isomers of butane. So I'm going to write question 7b. I will write isomers of butane. Now but means 4 carbons, so we'll have C single bond, C single bond, C single bond, C. That is because we are having ane means it's single bond. It's an alkene. And the second one will be where we will have 3 carbons and 1 carbon will be attached here. So each carbon you should show with 4 valencies and write H everywhere because it's a hydrocarbon. Each carbon must have 4 valencies. See here. One, two, three, four. This will be 1, 2, 3 and the 4th valency. For this one, 1, 2, 3 and the 4th valency. And for this one, there will be 1, 2, 3 and here 4th valency. So these are the two isomers. So this becomes your N-butane and this becomes your isobutane. Okay, now although they have not asked you, they can ask you even the IUPAC name. So N-butane becomes just plain butane, but here it becomes the longest chain is 1, 2, 3 carbons, so it will be a prop N. And the second carbon has got this group which is methyl group. So IUPAC name is going to be 2-methyl propane. Once again, second carbon has CH3 group which is methyl group. So 2 mentions the position of the methyl group and the longest chain has got 3 carbons. So it becomes prop and single bond means in. All right, this is our first part. Let's come to the second part. The second part says draw the structure of pentanoic acid and but2-ine. So pentanoic acid, as you can see, this word pent means there are 5 carbons. So we'll write 1, 2, 3, 4, 5. And each carbon must have the 4 valencies. All right, now here we have shown single bond because it has got N. That means single bond. Now oic acid, this is the functional group. The functional group oic acid is dash COOH. So our thinking step is it should be dash COOH. So the last carbon over here means the first carbon. The first carbon over here, we will show double bond O and single bond OH. So this becomes your COOH group, and you check for this carbon 1, 2, 3, 4 valencies. So all 4 valencies of carbon are satisfied. Then we write H everywhere. Then we come to the second one. What does but mean? But means there are 4 carbons. So 1, 2, 3, 4. Now 2-ine. What does ine mean? Ine means a triple bond. The second carbon. So if I put triple bond here, this will be my first carbon. If I put triple bond here, that will be my second carbon. So I will write this. That becomes your triple bond, and that takes care of this ine. Now this becomes the third carbon, this becomes the fourth carbon. If you count from this side, first carbon, second carbon. So whether you count from this side or this side, it will be the same. Now each carbon must have how many valencies? 4. So write H, H, H. This carbon, how many valencies does it have? 1, 2, 3, 4. So you cannot add any hydrogen to this. This carbon also 1, 2, 3, 4. So you cannot add any more hydrogen here. But this carbon has only 1 valency. So 2, 3, 4. So that makes 4 valencies for this. Now for each valency, attach hydrogen. So this becomes but2-ine. The last question says differentiate between substitution and addition reaction. So this type of question we have to draw 2 columns. It is for 1 mark, so probably 1 difference is more than enough, but let's see how we write it down. I have made the columns like this by writing substitution reaction and addition reaction. So first point I have represented as the first bullet and the second one with the second bullet here. So the first point is the definition, which you will find in any textbook. What is the keyword over here? Is the direct displacement or substitution. And here it will be the attacking reagent. It adds up across the double bond or a triple bond. So if it is direct substitution, it will be in alkanes because there is only presence of single bond between the carbons. And here it will be possible in alkenes and alkynes. So these are the keywords. Now, although it is 1 mark, it's better to write an extra point over here, because we do not know whether the examiner is going to consider only the definition or the examiner wants another point apart from the definition. Okay, so that finishes the entire paper. We have solved each and every question from this question paper. In section 2, we have to attempt only 4 questions. So choose the questions very carefully where you will get maximum marks. And I hope you have understood how to solve the paper to get maximum marks. Now what you should do is, when you are looking at this paper, once again, you pause it after reading the question, write the answers, mark the keywords, check it with this. Okay, so when you are solving this question along with me, ideally you should look at the question paper, put the video on pause, and then write your own answer and then correct it when you look at the correct answer. Understand the way the work is to be presented. That is what is going to give you full marks, along with the thinking that goes with it, and also the way you write it down and the accuracy of it. Okay, so I'm sure you are looking at it because you are appearing for the exams, and so all the best for your exams. Thank you for watching.